So we are discussing the periodic table. In the periodic table, we have discussed that we have 18 groups and 7 periods in the periodic table. The period number, it tells you, what does the period number tells? It tells you how many shells there are. Okay, how many shells? What is the meaning of shell? You know the atomic structure. Positive charge is in the center. That is your nucleus. This is my first shell. This is my second shell. Okay, so these are my shells. So if I ask you that if my period number is 3, then how many shells are there? 3. 3. It is written that period number is equal to shell number. So note it down in your notebook that period number is equal to shell number. If period number is 3, shells are 3. Period number 2, shells are 2. Okay. And this is a thing about periods. Now let us talk about groups. Groups are your vertical columns. Okay. These are your groups and these are your periods in the periodic table. So if we talk about group, then they have the same number of electrons in their outer shells. Okay, so if I am having group 1 elements. So how many outer electrons are there? 1. Group 2 element, how many outer electrons are there? 2. Outer electrons means the electrons which are present in the outermost shell, that are also known as valency electrons. Okay. So group number is the same as the number of outer shell electrons except for group 0. In noble gases, group 0 is a group. We'll study about group 0 in the next slide. It is the group for noble gases. So in your level, you can remember that the groups are 8 and periods are 7. Now, valency electron, it dictates how an element reacts. So the elements in group 1 all have similar reactions. Okay, for example, in group 1, you have lithium, you have sodium, you have potassium. So whatever reaction the lithium is giving, the same reaction sodium is giving and the same reaction potassium is giving. Got it?
Yes.
So I think 2 things you have to be clear very short, that period number is equal to shell number. Second thing is that if elements are present in the same group, then their chemical properties are also same and they have same number of valence electrons. Okay.
Okay.
So you want to write it down in your notebook or you want to take a sketch?
I'll write it down.
Okay, but do it fast because our 20 minutes are wasted. Okay.
Actually, I'll take a screenshot.
You will take a screenshot?
Yes.
Okay. So take it, then we'll move further.
But I'm not able to take it. I'll do it
Sorry?
one more time. I'm not able to take the screenshot.
So you can write it down, okay? Write it down. But don't write the entire slide. Write down only important things, okay? I think you are big enough to write down the important things, right?
Yes.
Okay. Write it down.
Okay, done.
Are you saying something?
Done.
Written?
No, now the screenshot is working. I took it down.
So this is your
Screenshot.
homework question for today. That radioisotopes can be used to check pipes for leaks. Explain how this works. How could you tell that a pipe had no leak? So this we discussed in the last session. Uses of radioisotopes to check for leaks. Remember where we have used a machine called Geiger counter. It beeps whenever there is a radioactive element present, right?
Yeah.
So take a screenshot. Homework question.
Done.
Okay. So yes, now group 0. Group 0 will study, as I told you, group 0 is a special group. Why it is special group? Because the elements which are present in group 0, they have a very stable arrangement of electrons. Okay, and stable arrangement of electrons means that their outermost shell is completed. Okay, so their atoms all have 8 outer shell electrons. Okay, remember I told you that in K shell, 2 electrons can fill. In L shell, you can fill 8 electrons. So 8 electrons are filled, so that's why it is stable. Except for helium. In helium, atomic number is 2 only. So only 2 electrons are filled in the first shell, in the helium case. Because it has only one shell. And in K shell, you can fill only 2 electrons. So it makes the group 0 elements unreactive. So group 0 elements are reactive or unreactive? Unreactive. Why they are unreactive? Because they have completely filled their outermost shells. They do not need any electron. They do not want to lose their electrons. That's why they are unreactive. See the atomic structure for helium. Its atomic number is 2. This is my first shell, K shell. 2 electrons are filled here. Okay. So full outer shell of 2 electrons, it is stable. Neon. Atomic number of neon is 10. So 2 electrons are filled in the first shell, K shell, and remaining 8 electrons are filled in the L shell. So it have full outer shell of 8 electrons. That's why it is also stable. If we talk about argon, so remember the names. He means helium, Ne means neon, Ar means argon. They all are your gases. Okay. So argon also, its atomic number is 18. So to fill 18 electrons, in the first shell you can fill 2. In the second shell you can fill 8 electrons. And in the third shell you can fill 8 electrons. So become 8 plus 8 plus 2 is equal to 18. Okay.
8
So
plus 8
it is have
plus
an outer
2
shell of 8
equal to
electrons. It is also stable. Here why group 0 is called a special group?
What?
Is it clear to you why group 0 is called a special group?
Yes. Oh, okay. Yeah.
So read this slide once and take a screenshot. If you have any doubt, let me know.
Okay. Done.
Okay. Now potassium. You have to solve this question. Solve it in your notebook and tell me this is potassium. Its atomic number or proton number is 19. So you have to arrange the 19 electrons in shells. So inner shell has dash electrons, next shell has dash electrons, next shell has dash electrons, and next shell has the remaining dash electrons. So tell me what should come here. Please read the slide, see the atomic structure of potassium, and tell me the answer.
Mm. So, inner shell has 1.
1. Are you sure?
No, sorry, 2.
Yes. Next shell has?
8.
Very good. Next shell has?
8.
Very good. Next shell has the remaining dash electron.
1. 1.
Yes. So its configuration would be 2, 8, 8, 1. So if you add 2 plus 8 plus 8 plus 1, you get the answer as 19. Okay, that is your proton number. I hope it's clear.
Yes.
Okay. Now there is an element which is rubidium. It is the 37th element in the periodic table. 37th element, that means its proton number is 37. It is in group 1, period 5. Now tell me how many shells are there if it is in period 5?
Hey students! Interested in boosting your studies? Enroll now at Keddy Edtech. We offer online tuition for the Cambridge curriculum, grades 6 to IGCSE, AS, and A-level. Start learning with us today.
If it is in period 5,
Yes. Then how many shells are there?
it will be, wait, will it be 8?
No. I just told you the significance of period. Remember?
Yes,
I've just written.
significance of period.
Yes,
It's a
periods
shell.
is equal to shell.
Shell.
So if it is in period 5, so how many shells are there?
How many, if it's in period 5, how many shells are there, right?
Yes.
Uh,
It is written here period is equal to shells. If period is 5, then shells is equal to?
5.
Yes, it is very simple. Shells is equal to 5. And it is in group 1. That means valence electron should be? Outermost electron should be?
What?
Yes.
Wait.
So this is the significance of periods and group number. That if period number
Yeah.
is 5, number of shells is 5. Period number is 4, number of shells is 4. And what about this group 1? Group 1 means that the valence electron is 1. Okay, now you have to write down the electronic configuration, so you can easily write it now. Okay, how? In the first shell, 2 electrons can come. In the second shell, 8 electrons can come. In the third shell, 18 electrons can come. 18 plus 2 plus 8 is 28. We have to fill 37. Okay, then again, you have to fill 2 more, right? Because there are 5 shells, 1 shell, 2 shell, 3 shell, 4 shell, 5 shell. That means you have to fill 2 blanks more. Okay, so in the fourth shell, 8 electron can come and last is 1. So our both conditions are satisfied, shells are also 5 and the valence electron is also 1, and if you add them it becomes 37. Is it clear how to solve such type of question?
Yeah.
Read it once, take a screenshot.
Mhm. Done.
So this is also your homework question. I hope you can now do this. That an element has 5 valence electrons, which group is in it, and how many electron shells do atoms of period 3 have, right?
Yes.
Take a screenshot. Done.
Wait. Almost done.
So now we are going to study about the metals and non-metals. So this is very important table. You just have to learn it. Metals are good conductors of electricity and heat. If we talk about non-metals, they are not good conductors of electricity or heat. Metals have high melting point and boiling point. Okay, that's why they are solid at room temperature. But non-metals are gases at room temperature because they have lower melting and boiling points. Metals are hard, they are strong, they do not shatter if you hammer them. But solid non-metals, they break up easily. That means they are brittle. Brittle means the tendency to break the tendency to break easily is called your brittleness. Metals can be or malleable, they can be or ductile. Malleable means they can be hammered into different shapes, and ductile means they can be drawn out to make wires. For example, copper. Copper is a metal which is hammered such a high extent that it become a copper wire. Okay. Solid non-metals, they are not malleable or ductile, so you just have to write the no word here in the case of non-metals. So metals are shiny, non-metals are not shiny, so it is very easy. Metals are shiny when they are polished, but non-metals, they look dull in the solid state. Metals, they make a ringing noise when struck. They are sonorous. Okay, many of the schools, you have heard the volume of the drum beat also. So it produces a ringing sound when it is struck. They are sonorous. Sonorous means they produce the ringing sound. So you should know the meaning of sonorous. You should know the meaning of malleable, ductile. Okay, the meanings are written here only, the definition. While solid non-metals, they break up when you strike them. If you strike solid non-metals, they break up. Metals have high density, they feel heavy, but as solid non-metals have low density, and most of them are gases, so gases have very low density. Metals form positive ions when they react. For example, sodium is a metal. When it reacts, so it loses its last one electron, so it becomes Na plus. So it will form positive ion. And non-metals, they form negative ion. For example, chlorine. Okay, it gains one electron. So chlorine is a non-metal. Oxygen forms O2 minus and oxygen is a gas. Okay, it is also a non-metal. Metals react with oxygen to form oxides that are bases. That means metallic oxides are basic. If you write MgO, magnesium oxide, okay, it is a metallic oxide, it is basic. And your non-metallic oxides, for example, CO2, carbon is a non-metal, its oxide is carbon dioxide, they are acidic. So you have to remember that metal oxides are basic and non-metal oxides are acidic. Is it clear?
Yes. Yes.
Read it once, read the properties of metals and non-metals, take a screenshot and you have to write it in your note.
Okay. Done. I'm done.
But there are some exceptions here. Okay, these are very important. That not all metals are hard solids. We have studied that metals are hard, but no, sodium and potassium, they are exceptions. They are not hard. They are so soft they can be cut with a knife. Sodium and potassium we are talking about. Then we have studied that metals form positive ions, right? But hydrogen is a non-metal. It still forms positive ions. So this is also your exception. Next, we have studied that metals are good conductors of electricity and non-metals are bad conductors of electricity. But carbon is a non-metal and its one form is graphite, which is a good conductor of electricity. Okay, so this is also an exception. Now, what we have studied that metals have high melting point and boiling point, while non-metals have low melting and boiling point. But carbon, diamond, which is made from carbon, it have high, it is very hard and it has a very high melting point. So these are some exceptions. These are very important to learn these exceptions. Okay. So write it.
Yes.
Take a screenshot of it. Read it once.
Done.
So this you can see that metals are used to make drums. So think of two reasons they are used to make drums. So what are these two reasons? That metals are sonorous. They produce ringing sound when they are struck. And second thing is that they do not break easily. Otherwise, if you beat the drum, if drum breaks, then there is no point of beating it, right? So metals do not break easily. That means they are not brittle. Okay? Not brittle. Which is the property of non-metal. Clear?
Yeah. Yes.
Okay, so let's end the session here. Please let me know if you have any doubts in this session. In the next class, we are going to learn about the uses of metals.